Hey, eighth grade. So our learning target today is I can interpret data in a scatter plot using something called correlation, or how are things connected or correlated. So correlation is a relationship between two variables, the variable x and the variable y. So a connection between what's going on between these two variables. So some things that we're going to talk about is when is it positive, when is it negative, and are there times that the two variables just really aren't connected at all to each other. So positive correlation means two things. It means up, up. As one thing goes up, the other thing goes up. It's called positive correlation. Here's what's tricky. Positive correlation could also mean down, down. Sort of tricky, sort of a confusing thing. And maybe I'll graph that one at some point just so you can kind of see how that works. I might add just a little graph there so you can see how that works. All right, so in positive correlation, as one variable goes up, the other variable also goes up. As one thing goes up, other variable also goes up. Okay, so if we think about an example, would be this. If we were selling ice cream, go ahead and write ice cream over here. And then let's compare that to the temperature. So here's our x. Of course, here's our y-axis. And let's just write our temperature as 0 degrees, 20 degrees, 40 degrees, 60 degrees, 80 degrees, 100 degrees. Assuming Fahrenheit temperature like we measure in the United States. And then we have our ice cream sales. Let's say we have 10, 20, 30. So we're talking thousands of ice cream sales, maybe for a big corporation like Dairy Queen, something like that. I'm going to erase that because my pen is not working so well here, but 10, 20, 30, 40, 50, and so on. So we would say that if it's a really cool day, we're not going to sell a lot of ice cream. So not very many, not as much. So kind of down here in this range. On the flip side, if we had a 100-degree day, we're going to sell the most amount of our ice cream. So it would vary depending on Dairy Queen. And then we could assume that in a medium temperature day, 50s, 60s, 70s, something like that, we'll sell kind of an average number of ice cream treats. So we would say that our trend is kind of trending this way. So if we were to box that in, we could throw an arrow on the end and say that that's what our arrow would look like. That's kind of the trend of our data. So we're saying as the temperature increases, our ice cream sales also increase, known as positive correlation. So that's an example of something called positive correlation. So we can take a look at another example. On our other example, we would say, well, what about when else would we have a positive correlation? Well, one really obvious one is when we compare our test scores, we just saw this when we were graphing the other day, with our hours that we study. So if we study 0, 1, 2, 3, 4, 5, 6 hours, and our test scores 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I know I'm writing over the top of things. I'm just having a hard time with this pen here. Sorry about that. So if we don't study at all, 0, we're probably going to assume we're not going to do very well. However, if we study a lot, so like 6 hours, let's say, is the most we could study, that's all the time we had, we could potentially get a perfect score. Or study 5 hours. If we study kind of a medium amount of hours, we'll kind of get a middle of the road score. So our trend again would be something like this. So our data is kind of pointing in this direction. Our arrow is going out in this direction. So we'd have this positive correlation. Now I think I'll come back and talk about this other example in just a second. So I'll give you some time to think about that. Work on that. All right, well, maybe we'll do that one again. So let's try another example when we have this tricky one, this down-down correlation. So let's talk about, again, temperature. So we'll put temperature over here on the x-axis like we were doing before as the temperature. So 0, 10, 20, 30, 40. Actually, you know what? I'm going to scale it by 20s because otherwise I'm not going to fit it on this graph here. Sorry, guys. 0, 20, 40, 60, 80, 100 when the temperature is super duper hot. What would be a situation where we have a down, down? So as the temperature gets hotter, what thing would we be selling that also would go down? So it's super, I'm sorry, the temperature is decreasing. So the temperature is getting colder. What thing would be selling that also would go down? So getting super cold out, we would say that ice cream would go down, right? So temperature, ice cream. Well, we've already looked at that one. What about if we talk about the number of sandals that we would sell? So we would say, again, in millions, 10, 20, 30, 40, and 50, something like that. So let's say the temperature is at 100 degrees. Are we going to sell a lot of sandals? No, not really. So 100 degrees, we're not going to sell a lot of sandals. So we would say temperature is at 100 degrees. Or whoops, yep, sorry about that. I'm messing that up, guys. I'm so sorry. Temperature is at 100 degrees, so it's super hot out is what I meant to say. I'm having trouble with this pen, so then I'm getting distracted. The number of sandals we'd sell would be a whole lot of sandals. Temperature is really cold out. We would probably sell not very many sandals. So we would trend again in this positive direction. You don't have to write this one down if you don't have space for it, but just to give you an idea of a third example that would work. Up, up, or down, down. Okay? So let's go ahead and look at negative correlation. Negative correlation is one goes up, other goes down. Or as one goes down, other goes up. So as one variable increases, the other variable decreases. We have this opposite thing happening. Negative meaning opposites, like opposites attract. So our first example would be this. Hot cocoa sales. And the other thing would be our temperature outside. So our temperature outside, we'd say 0, 20, 40, 60, 80, and 100 degrees temperature. Hot cocoa sales, though, so we would say 10, 20. This pen is driving me crazy, you guys. I'm so sorry. I'm so distracted in this lesson. 10, hang in there with me. 10, 20, 30, 40, 50. So we're talking millions of hot cocoa sales, maybe at Starbucks, something like that. So we would go ahead and say, what if it's super duper cold out? We would sell a lot of hot cocoa, or the most amount, let's say, would be 50,000. On the opposite end of the spectrum, if it's super hot out, we're not going to sell a lot of hot cocoa. Middle of the pack, we'd sell a medium amount. So we'd have this trend this time going down. That downward arrow gives us that trend going down. That means that as the hot cocoa, as the temperature, I should say, as the X, as the temperature gets hot, the hot cocoa sales go down. So as one thing goes up, the other thing goes down. That's a negative correlation, opposite direction. So what's another example that we could say that's a negative correlation that I kind of like to use is a really good real life example. Our miles that we drive, what happens about that? 0, 1, 2, 3, 4, 5, 6, and so on. The miles that we drive, what happens to the gas in the tank? So what happens to the gas tank? So we would say here's full and here's empty. So if we had 0, 2, 4, 6, 8, 10, 12 gallons of gas, a full tank, let's say is 12 gallons of gas, which isn't a very big tank, but I'm out of room there. If you haven't driven at all, you have a full tank of gas. If you've driven 1 mile, you're going to lose a little bit of gas, and 2 miles, you'll lose a little bit of gas, and kind of keep on decreasing throughout this process until eventually it's empty. So we would have this decreasing pattern as the more we drive. So it's this opposite relationship. The more X's that happen, the more we drive, the less gas we have. The gas decreases. The more we drive, gas going up, or the miles going up, the gas in the tank goes down. We lose gas in the tank, negative correlation. Okay, now if I'm going too fast, pause that video. The last correlation is known as no correlation, when there's no pattern relationship in the variables. Example would be adult money. So we're talking thousands of dollars. So adult money in thousands. So we would say, what about 10, 20, 30, 40, 50, and so on. Okay, And then we're going to compare that to something like your shoe size. Now, some people could argue and say, well, little tiny kids have tiny feet and they don't make any money. But in general, is it always, I shouldn't say in general, always, is there a relationship between how much money you make and your shoe size 5, 6, 7, 8, 9, 10, 11, and so on? Is there a direct connection between those two things? No. So there is absolutely no pattern because you could have a size 10 feet and not make very much money, or you could have a size 10 shoe and make tons of money, or you could have a size 40, or you could have a size 6 shoe and make 40 grand. It just really, there's no pattern between your shoe size and how much money you make. So we would say no correlation there, no pattern at all. And the last example before our summary today is what about like your hair length? So if we were measuring it in centimeters, measure it in centimeters. So 1 centimeter, 2 centimeters, 3 centimeters, and so on. And we'll compare that to your IQ, how smart you are. So we have all these numbers in your IQ increasing. Is there any relationship to how smart you are and your hair length? No, not at all. I mean, there are bald people that are super duper smart, and there are bald people that maybe struggle as learners. So absolutely no connection between your hair length and how smart you are in your IQ. Not at all. Now, some people that have maybe short hair and are super smart would argue that, but generally in life, there is no connection between those two things. Your summary for today is that when you have a positive correlation, it's up, up, but it also can be, which is sort of tricky, down, down. The key is that the graph is trending this direction. Graph trends this way. So we have that positive correlation. On the flip side, then, negative correlation is the other situation where it's this or this, and it's trending down, downward trend. Okay, so we have positive correlation, we have negative correlation, and then we're talking about the no correlation, no pattern at all. Keep in mind that this is your y-axis and this is your x-axis. So this is your horizontal and this is your vertical. Notice that V right up here. This helps some kids. This is known as your vertical axis because it has the V on there. I don't know if that helps you. So our other thing that I would like to have in the summary is that there's something called strong correlation and weak correlation. We didn't talk about this a lot in the lesson, but if the points are super, super tight, obviously this is a positive. Points are super tight. We would say that this is a strong correlation. Tight points. It has strong correlation. This one here, okay, still has the same pattern up. This one we would say has a weak correlation. So it's still working there, but it's a little bit weaker. See, the points are a little bit more spread out. Still positive trend, but it's just a little bit weaker. So there's weak and there's strong. You might want to add that to the bottom section of your notes if you can squeeze that in on correlation. So your homework for tonight is to finish page 15 and page 16 due tomorrow. Have a fabulous night, 8th grade.